Hi, my name is Venkat Pullela. I'm a distinguished engineer at Broadcom. I work on the switching architectures team and design both hardware and software architecture. Today we are going to talk about network programming language, NPL for short. NPL is designed for specifying packet processing pipelines and implement them efficiently on programmable hardware on multiple architectures. For example, Jericho 2 and Trident 4 from Broadcom. Both are fully programmable architectures. NPL covers basic constructs like parser, match action table editor that many of our other languages have. And NPL also has advanced constructs like multi-lookup table, strengths, and functions. These are all advanced to support parallelism and implementation efficiency. And we will get into the details of each one of them as we go forward. NPL program is a sequence of NPL constructs, and these constructs are mapped to a pipeline, basically. So, and like I said, these things are sequentially executed. Program is the only construct where the constructs are executed in a sequence. And the backend compiler, that is target specific, might reorder them. So reordering is done so that they can be optimized and they can be parallelized and might fit the hardware better. So they can be reordered. Let's look at what are these constructs, right? So NPL supports a multi-stage reentrant parser. So parser begin might start a parser and stops at a certain point, and the output of or the metadata generated by the parse begin is used by some more lookups after that. And then the good thing about NPL and the multi-stage reentrant parser is that you can restart and continue that. So this is going to give very powerful abstractions that can be implemented very efficiently. Let's look at a couple of other things that program has. So here you see a MAC table being looked up twice. 0 is a lookup 0, 1 is a lookup 1. This could be your source lookup, this could be your destination lookup. You can see that this also has conditional so that you can do branching and do specific lookups or execute some special functions or functions that only when there is a specific condition that is met. So here you are seeing some functions. Essentially this is a Boolean logic, and it could be making some decision logic based on the constructs and based on the metadata and packet flow. Program construct also combines lookup tables and parser constructs and functions to make an efficient implementation, because program and a switching pipeline is not just a data processing pipeline, it's also a decision making pipeline. So certain decisions like do layer 3 forwarding can be called from the program. Under conditionals, you can say if only layer 3 is enabled, then we want to go to layer 3 forwarding. So program construct combines parsing, multi-lookup tables, and functions and other constructs to make sure that the full end-to-end pipeline is programmed. NPL supports standard types of bit, which indicates 1 bit, bit array, which is an array of bits. You can use that to specify a field. You can specify a var bit. Var bit is to specify fields that we don't know the length and how many bits are there at any given time. The number that is used in the specification though is the maximum number of bits that might form the var bit. So these three form the standard data types. Struct is the only user defined type, but we use the struct for doing multiple things. Here you clearly see struct is used to describe one header. We are describing a VLAN tag and it has some fields in it. And same struct is used also to specify a group of headers. So here you can see a layer 2 type and a VLAN type is a group of each one is a header of this type, and then they are grouped as another structure. Same struct is also used to describe a packet of these groups. So there is a 3-level hierarchy. There is a packet that has header groups, and each header group has a set of headers, and the headers can be described with a structure. So structure is the only user defined type that is used to aggregate the types. Struct is also used once a header is defined through a structure, struct can also be used to describe a bus. Bus and the bus type and the bus variable name. Imagine you have a pipeline and you have a bunch of tables and lookups and then functions and various other constructs. They're all typically connected through a bus. Having a bus construct naturally in the language makes it easy for the power users or the programmers to think in their own language. They could create their own buses that intuitively points out the structure of the decision making of the pipelines. There are times where there is a lookup table that generates some fields that are used by another table or maybe some more, and there could be read only or read write, and all of them can be very intuitively used with a bus structure. If you notice, actions are missing from the logical table definition. Action is moved away from the table scope into the global scope. One of the major decisions of their hardware architecture as well as NPL is separation of match actions into multiple primitives. And these smaller primitives make it easy to parallelize them because they reduce the dependencies. They become lightweight. Because they are lightweight, you can the throughput goes up. So match action gets disaggregated into a lookup. Match also produces results. These are result objects, and action is separated into a separate primitive, and then there is processing of the result. And these smaller primitives are a little easier to handle. They increase the throughput, they make it more intuitive for the power user to program and map it to the hardware. Logical table also has two methods, one for constructing the key, another for handling the results. Key construct method can be used to construct the key under different conditions, maybe for different lookups, or you could even have a conditional that could say for multicast this is what I need to do. So you can clearly see for if it is lookup 0, you are trying to use the source address, and if it is lookup 1, you are using a destination address. So that you are handling both the lookup 0 and lookup 1 and getting different keys through a construct method. Fields assign similarly has handling for lookup 0 as well as lookup 1. Packet processing is not only data processing of packet header fields or the metadata that is generated through lookup tables. There's a lot of decision making that happens on where to send the packet and how to modify the packet. Function primitive is used to describe those logical functions. Function is also used for doing arithmetic and other logical operations. And once the match action table is disaggregated, the action has moved out of table scope to the global scope. These kinds of functions will take the decision making to a global scope, and that will allow multiple parallel features to be implemented. So here I am showing an example of a simple function that is trying to look at how do I get a VLAN if the packet is tagged. It could be this is another complicated, maybe not so complicated function that is doing more and more of logical computation and finally arriving at some decisions. And you could imagine maybe 1,000 lines of such logical or Boolean equation and logical code and making different decisions. The decision making and the pipeline is viewing the pipeline as a decision tree is a very important part of the design of NPL as well as the hardware architecture. As we discussed, packet processing is not just data processing, it's also decision making. But decision making happens over the pipeline. That means there are some decisions taken, like there may be a few of the decisions as well as something from the bus, and there is a local decision that's made. And that is forwarded on the bus, and then additional decisions are done one at a time. So there is a construct in NPL that is designed to parallelize as well as to help with the decision making. This is a decision making construct called strength. What I am showing here, imagine there is a table 1 and there is a table 2. And both of them are producing the same objects. Now we need to figure out which object is finally going as part of the final result. And as we discussed here, there may be similar object or same objects that is on a bus here. This could be bus 1. First, there is a strength associated with each one of these fields, and that strength is nothing but priority. So the whole idea of strength is a priority based resolution of dependencies of objects. These objects could be different widths and different types and things like that. So the strengths from each one of them, which is nothing but priority, are put through a profile table. Profile table helps us with changing the priority at runtime. That means imagine table 1 has higher priority than table 2. You could change by changing the entries in this profile table. You could prioritize table 2 to become priority, higher priority, and table 1 to be lower priority at the runtime. So that resolves which one has the highest priority. So this priority is fed into the object selector. So that field from either T1 or T2 or the field from the bus is selected and put out as a final result. In a way, you are looking at multiple fields and associated priorities, and based on a dynamically changeable priority at runtime, you are arriving at a result. And many such strengths can be used across the pipeline to make decisions. This also allows us to do parallel processing of more and more computation. What happens is there are fields and there are tables that have dependencies. Strength construct allows you to make them or execute them in parallel so that it produces more throughput. Once decisions about packet modifications as well as where the packets go, then editor construct that has a couple of these functions that will allow you to modify the packet using add header, delete header. Both add header and delete header use the same headers that are defined in the parser so that the output packet that comes out is still a valid packet. To end the whole NPL introduction, we're going to talk about special functions. These special functions cannot be described in NPL. It could be a vendor-specific proprietary functionality, but we need to be able to provide an interface to it. So the special function construct provides 3 things. Provides an input object, provides an output object, and provides something called a mode of operation. So this will allow you to define what kinds of inputs go into the special function under different situations, and then when the outputs come out of the special function, where those outputs go out. So the same mode is also used to control how special function operates. Could be mode for IPv4, could be a mode for IPv6, or could be mode for multicast. To summarize, NPL is a programming language, domain-specific programming language that is to support multiple architectures efficiently, and then has many advanced constructs that will allow you to exploit the parallelism supported in the hardware and to make sure that it maps naturally to the hardware, is easy to be used by power users and things like that. For more details and a detailed explanation of what we discussed today and more things, you may go to nplang.org.